CBSE Class 10 Polynomials Chapter 2. I'm going to explain you sum of the zeros and product of the zeros concept. Let's start. First of all, general form of quadratic polynomial. General form of quadratic polynomial is ax square plus bx plus c. This is the general form of quadratic polynomial, where a, b, c are integers. Okay. If you put here is equal to 0, it will become quadratic equation. There is difference between quadratic equation and quadratic polynomial. We are discussing about quadratic polynomial, so there will not be any 0 here. This is a quadratic polynomial. Degree of quadratic polynomial is 2. Highest power is called degree, and degree of quadratic polynomial is 2. ABC are just constants. So sum of zeros, actually quadratic polynomial has 2 zeros. Zeros are denoted by alpha and beta. Zeros are always denoted by alpha and beta. So quadratic polynomial has 2 zeros. Zeros means value of x. Value of x is nothing but zeros. For what value of x the polynomial will become 0? When you substitute the zeros, the whole equation will be equal to 0. Okay, so just remember that quadratic polynomial has 2 zeros, and sum of the zeros alpha plus beta, sum of the zeros is given by minus b by a, and product of zeros is given by c by a. So please remember these two formulae. Find the sum and product of the zeros of the following quadratic polynomials. Here 6 quadratic polynomials are given. He is asking us to find sum of the zeros and product of the zeros. Let us start solving one by one. The first bit is 3x square minus 4x plus 7. Okay. Now, first of all, write the standard form. Standard form of quadratic polynomial is ax square plus bx plus c. A is equal to 3. A value is 3. B is equal to minus 4. C is equal to 7. After getting ABC values, let us find sum of zeros. Alpha plus beta, sum of zeros is given by minus b by a. Minus, what is b value? Minus 4. What is a value? 3. Minus of minus plus, so 4 by 3 is sum of zeros. Similarly, product of zeros. Product of zeros is given by alpha into beta is equal to c by a. What is c value? C is 7. A is 3. 7 by 3. So we got sum and product of zeros. That's it. In the second bit, the quadratic polynomial is minus 2x square plus 6x minus 7. Is that okay? This is the quadratic polynomial. Now, standard form of quadratic polynomial is ax squared plus bx plus c. Note down ABC values. A is equal to minus 2, b is equal to 6, c is equal to minus 7. Now we have the formula for sum of zeros. Alpha plus beta is equal to minus b by a minus, what is b value? 6. A minus 2. Here you can cancel both the minus, and you can even simplify 2 how many times? In 6, 3 times. So the final answer is 3. Sum of the zeros is 3. Product of zeros. Alpha beta is equal to what? C by A. What is C? Minus 7. What is A? Minus 2. Both the minus will get cancelled and product of zeros is 7 by 2. The third equation is x square minus 2x plus 4. General form of quadratic polynomial is ax square plus bx plus c. Can you tell what is a value? A value is 1. Here, if there is no coefficient, you should assume that 1x square. So a value will be 1. B is equal to minus 2. C is equal to 4. Formula to find sum of zeros. Alpha plus beta is equal to minus b by a minus b value is minus 2. A is 1. So answer is 2. Minus into minus plus. Product of zeros. Alpha beta is equal to c by a. C is 4. A is 1. So product of zeros is 4. In the fourth bit, the quadratic polynomial is 6x square minus 7. So here, there is no x coefficient. So you can write 0x minus 7. Standard form of quadratic polynomial is ax square plus bx plus c. A value is 6. You can see a value here. There is no x coefficient, so b can be taken as 0. C value is minus 7. Don't forget minus. Sum of zeros formula is minus b by a. B is 0. 0 by something. 0 by something is 0. 0 by anything is 0. Product of zeros formula is c by a. C is minus 7. A is 6. That's it. In the fifth bit, the quadratic polynomial is minus x square minus x plus 1. Standard form of quadratic polynomial is ax square bx plus c. Write down ABC values. What is the a value? Minus 1. B is equal to again minus 1. C is equal to 1. Sum of zeros is given by minus b by a. What is b? Minus 1. A minus 1. So minus of minus 1 by minus 1 is minus 1. Product of zeros is c by a. What is c? 1. A minus 1. So the answer is minus 1. So the sixth equation, sixth polynomial is 4x square minus 2x. The standard form of quadratic polynomial is ax square plus bx plus c. A value is 4, b value is minus 2, c is 0. There is no constant here. So c is equal to 0. Sum of the zeros formula is minus b by a minus b value is minus 2. A is 4. Minus of minus plus 2 by 4. 2 ones are 2 twos are. So sum of zeros is 1 by 2. Product of zeros formula is c by a. C is 0 and a is 4. 0. Alpha, beta are the zeros of the quadratic polynomial. The quadratic polynomial is ax square plus bx plus c. He's asking us to find the value of 1 by alpha plus 1 by beta. First bit. Let us start. So given quadratic polynomial is ax square plus bx plus c. Sum of the zeros minus b by a. Product of the zeros c by a. Using this sum and product, we have to find the value of 1 by alpha plus 1 by beta. So let us take LCM. When you take LCM, beta 1s are beta, alpha 1s are alpha. In the denominator, you will have alpha into beta. So in the numerator, we are having sum of zeros. Can you tell what is the value of sum of zeros? Alpha plus beta value is? Minus b by a. Substitute minus b by a in the numerator. And in the denominator, we are having product of zeros, alpha, beta. We already got product, which is nothing but c by a. Both the denominators will get cancelled and the final answer is minus b by c. Given quadratic polynomial is ax square plus bx plus c, in the second bit they are asking us to find alpha cube beta square plus beta alpha square beta cube value. So first of all, let us write the polynomial, which is ax square plus bx plus c. Sum of zeros is minus b by a and product of zeros is c by a. So in the second bit, they are asking us to find alpha cube beta square plus alpha square beta cube value. So you can take common. Alpha square beta square can be taken common. So here, after taking alpha square beta square common, one alpha will remain. Here, beta will remain. Now this part, alpha square beta square can be written as alpha beta whole square, alpha plus beta. So we have both sum as well as product. What is sum of zeros? Alpha plus beta is minus b by a. What is product of zeros? C C by A whole square. So C by A whole square is nothing but C square by A square into minus B by A. When you are multiplying two fractions, you should multiply numerator into numerator and denominator into denominator. So C square into minus B is nothing but minus BC square. A square into A is A cube. When bases are equal, powers will be added. A square into A is A cube. This is your final answer. So in this particular problem, they are asking us to find alpha square plus beta square. Very interesting problem. I think this is third bit. Now we can get alpha square plus beta square from alpha plus beta whole square formula. Alpha plus beta whole square is nothing but a square plus b square plus 2ab. A plus b whole square formula. Alpha plus beta whole square is alpha square plus beta square plus 2ab. So you want alpha square plus beta square. So transpose this to the other side. Plus 2ab will become plus 2 alpha beta will become minus 2 alpha beta. So in this way you can get the formula alpha plus beta whole square minus 2 alpha beta is equal to alpha square plus beta square. So now let us substitute sum and product and find the answer. So alpha square plus beta square is nothing but alpha plus beta whole square minus 2 alpha beta. Is that okay? Now tell me what is alpha plus beta? What is sum? Minus b by a whole square. What is product? C by a. Let us simplify. When you square minus into minus, it will become plus. So you will get b square by a square. Minus will disappear when you square. This is 2c by a minus 2c by a. Here you have 1 numerator into numerator, denominator into denominator. Right? 2c by a. Now let's take LCM. I want to make the denominators equal, so I am multiplying with a and dividing with a. So b square by a square. I am getting 2ca by a square. So a square is the LCM. B square minus 2ac. This is my final answer. Alpha square plus beta square. Hope you understood this. In the fourth bit, the question is find the value of 1 by alpha square plus 1 by beta square. So take LCM. Beta square into 1 is beta square. Alpha square into 1 is alpha square, in the denominator alpha square beta square. So numerator alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta. So numerator is written as alpha plus beta whole square minus 2 alpha beta, and the denominator we can write whole square in the denominator. So we have some product also. Substitute sum of zeros and product of zeros. Let me substitute here. Alpha plus beta is minus b by a whole square. Alpha beta is c by a. Got it? Now alpha beta is c by a whole square. Let us simplify this part. When you square, I already told minus will disappear. You will be getting b square by a square. Minus disappeared. 2c by a. And in the denominator, you are having c square by a square. Here, try to make denominators equal by multiplying and dividing with a. So, b square by a square minus 2ac by a square by c square by a square. LCM is a square, b square minus 2ac by c square by a square. Denominator cancel. The final answer is b square minus 2ac by c square. That's it. By anything is 0. That's it. So the given quadratic polynomial is ax square bx plus c. So sum of the zeros is minus b by a. Product of zeros is c by a. And he is asking us to find alpha cube plus beta cube. So we have a formula alpha plus beta whole cube, which is nothing but alpha cube plus beta cube, 3 alpha square beta, 3 alpha beta square. You can take 3 alpha beta common in the last two terms. So let's take common. Let's take 3 alpha beta as common. Alpha and beta will remain inside. Take this entire term to left hand side, transpose it, plus sign will change to minus. Let us transpose. Alpha plus beta whole cube minus 3 alpha beta into alpha plus beta is equal to what? Alpha cube plus beta cube. So alpha cube plus beta cube formula is, remember this formula, alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. Please remember this formula. This is sum of the zeros. This is product of zeros. This is again sum of zeros. We already know what is sum and product of zeros. Let us substitute sum of the zeros minus b by a. Product of zeros c by a, and sum of zeros minus b by a. When you cube, minus will not disappear, minus will remain. So minus b cube by a cube minus into minus plus numerators multiplied 3bc, denominators multiplied a into a square. Take LCM. This second term should be multiplied with a and divided with a so that denominators will be equal. 3bc into a, 3abc, a square into a cube. This is cube. Now we have same denominator. A cube is LCM minus b cube plus 3abc. This is your final answer. So what is the given quadratic polynomial? P of x is equal to ax square plus bx plus c. What is sum of zeros? Minus b by a, product of zeros, c by a. They are asking us to find 1 by alpha cube, 1 by beta cube. So take LCM. Beta cube 1 za, beta cube, alpha cube 1 za, alpha cube, and in the denominator alpha cube, beta cube. So LCM is done. You all know from the previous problem what is alpha cube plus beta cube. Formula is alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. So alpha cube plus beta cube can be written as alpha plus beta whole cube minus 3 alpha beta into alpha plus beta by alpha cube beta cube. We can write alpha beta whole cube. This is sum of zeros, product of zeros, sum of zeros, product of zeros. We already know sum and product. Just substitute. Sum is minus b by a. Product is c by a. Again sum is minus b by a. Product is c by a. Okay. When you cube, minus will remain. So you will get minus b cube by a cube. 3 minus into minus plus 3bc by a square. 3bc by a into a square. In the denominator, you will be having c cube by a cube. In the next step, you will be multiplying and dividing with what? A. So you will be getting minus b cube by a cube plus 3abc. bc into a is 3abc by a square into a is a cube. Take a cube comma LCM minus b cube plus 3abc. In the denominator, you will have c cube by a cube. A cube will get cancelled. You will be getting minus b cube plus 3abc by c cube as the answer. So he is asking us to find alpha minus beta. We have sum alpha plus beta is equal to minus b by a. We have product alpha beta is equal to c by a. Making use of sum and product, we have to find alpha minus beta. This is little bit important question. So to find alpha minus beta, let us take a relation like alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. On applying roots on both sides, square and root will get cancelled. We get the value of alpha minus beta, which is nothing but alpha plus beta whole square minus 4 alpha beta under root. So whenever alpha minus beta comes, you will be using this formula. So here I'm going to write alpha minus beta is nothing but under root alpha plus beta whole square minus 4 alpha beta. Is that okay? Remember the formula?
Yeah.
Now substitute sum and product. You already have sum and product. Keep the root. Alpha plus beta is minus b by a whole square. Alpha beta is c by a. Correct? When you square, minus will disappear. Minus into minus, it becomes plus. So you will be getting b square by a square minus 4c by a. Numerator into numerator. 4c by a. We can make the denominators equal by multiplying with
A.
a to the second term. Second term multiply with a. So you will be getting b square by a square, 4ac by a square. A square is the LCM, b square minus 4ac. Separate the roots. B square minus 4ac numerator will be getting a new root. A square denominator will be getting separate root. Square and root will get cancelled. So your final answer would be b square minus 4ac by 8. That's it. The next problem is alpha power 6 beta power 5 plus alpha power 5 beta power 6. Let's take the question. Alpha power 6 beta power 5, alpha power 5 beta power 6. Let us take common. Alpha power 5 beta power 5 is taken as common. Alpha plus beta will remain inside. You can write alpha beta whole power 5 alpha plus beta. This is product of the zeros. This is sum of the zeros. Substitute the values. Product is c by a. Sum is minus b by a. C power 5 a power 5 minus b by a. Numerator into numerator, denominator into denominator. So you will get minus b c power 5 by a power 5 into a is a power 6. That's it. So The given quadratic polynomial is ax square plus bx plus c. Sum of zeros is minus b by a. Product of zeros is c by a. Using sum and product, we have to find the value of 1 by alpha minus 1 by beta. Let's start. 1 by alpha minus 1 by beta. Take LCM. Beta minus alpha by alpha beta. Take minus common. When you take minus common, this minus alpha will become plus, and this plus beta will become minus. I have already given the formula of alpha minus beta, which is nothing but under root alpha plus beta whole square minus 4 alpha beta. So let's write the formula of alpha minus beta, which is, keeping minus outside, the formula is alpha plus beta whole square minus 4 alpha beta under root by alpha beta. Now substitute sum and product. Sum is minus b by a. Product is c by a by product c by a. When you square, this minus will disappear. Minus is outside. We will get b square by a square. 4c by a multiplying with a and dividing with a, and this part will become reciprocal. Root is already there. Don't forget about the root. And this part is reciprocal. That means a by c. C by a will become a by c. So a into a square, a square. LCM is a square. B square minus 4ac. Roots can be separated for both numerator and denominator. So minus being outside, minus is kept outside. B square minus 4ac by square and root will get cancelled. AA will get cancelled. This is your final answer. Please write down. The next question is 1 by alpha plus 1 by beta minus 2 alpha beta. Let's write. Take LCM in this part. I'm not including this. Why? Because product of zeros I know c by a. So I can directly substitute c by a here. So I'm not having any sum and product here. यहाँ पर कोई सम नहीं है, प्रोडक्ट नहीं है, तो यहाँ पर एलसीएम की जरूरत नहीं है. इसको इंक्लूड मत करो एलसीएम में. सो एलसीएम ये पार्ट में एलसीएम बीटा वन सा बीटा प्लस अल्फा बाई अल्फा बीटा माइनस 2 अल्फा बीटा. अब हर जगह सम प्रोडक्ट आगे सब्स्टिट्यूट करिए. ये अल्फा प्लस बीटा की जगह माइनस बी बाई ए, अल्फा बीटा की जगह सी बाई ए, माइनस 2 अल्फा बीटा की जगह ए कैंसल, माइनस बी बाई सी minus 2c by a. Okay, so you need to take LCM. If you want, you can take minus common. When you take minus common, inside plus will remain. This is your answer. That's it. In the next question, he is asking us to find 1 by a alpha plus b plus 1 by a beta plus b. Let's take the question. 1 by a alpha plus b, 1 by a beta plus b. So let us take LCM. This will multiply 1, so you will get a beta plus b. This will multiply 1, so you will get a alpha plus b. Is that okay? And in the denominator, you will be having a alpha plus b into a beta plus b. Now I would like to take common in these two terms. A can be taken as common in the both terms. So when I take A as common, beta plus alpha will remain and B plus B is 2B. Okay, numerator simplification is done. Let's focus on denominator. We can multiply both the denominators. A alpha into A beta is A square alpha beta. A alpha into B is AB alpha. B into A beta, AB beta. Lastly, B into B, B square. Is that okay? Now, in the numerator, A into beta plus alpha plus 2B. In the denominator, A square alpha beta, fine. In these two terms, if I take AB common, if I take AB as common, I will get alpha plus beta plus b square. At this stage, you can see product sum of the zeros, product of the zeros, sum of the zeros. At this stage, you can substitute A into sum is minus b by A. A will get cancelled, plus 2b remains. A square. Product of zeros is c by A. 1a will cancel, plus AB. Sum of the zeros is minus b by A. Again, A will get cancelled, plus b square. Slowly we are heading towards our answer. After cancellation of A's, minus b will remain. Minus b plus 2b. Minus b plus 2b is remaining in the numerator. C. Square cancel na. AC. Here b into b and plus into minus b square, isn't it? And plus b square minus b square cancel, and the final answer 2b minus b is b. After cancellation of b square, you will have AC. That's it. Final answer. The next question, he is asking us to find the value of beta by A alpha plus B plus alpha by A beta plus B. As in previous case, we have to take LCM here also. Let's write down the question. Beta by A alpha plus B, alpha by A beta plus B. On taking LCM, these two will get multiplied. So beta into A beta plus B, these two will get multiplied. Alpha into A alpha plus B, denominators a alpha plus b into a beta plus b. Start multiplying. Beta into a beta square. Beta into b beta. Alpha into a alpha square. Alpha into b alpha. The denominator a alpha into a beta. A square alpha beta. A alpha into b. AB alpha. B into a beta. AB beta. B into b square. Now you can take common in these two terms. A is common. Beta square plus alpha square will remain. In these two terms, B is common. Beta plus alpha or alpha plus beta, both are same only, will remain. Here AB is taken common in the middle terms. A square alpha beta. AB is common, alpha plus beta remains, and lastly B square. So taking common is done. You all know alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta. B into beta plus alpha. A square alpha beta. AB alpha plus beta plus B square. At this stage, you have only sum and product. Everywhere you can see sum of the zeros and product of the zeros. Next step. In the next step, you will be substituting sum of the zeros and product of the zeros values and simplify. Let's go to the next step. A into alpha plus beta whole square is minus b by a whole square. 2 alpha beta. Alpha beta is c by a. That's it. Plus b into alpha plus beta is minus b by a. Numerator done, denominator substitution started. A square into alpha beta is c by a. A square into c by a, you can cancel, is plus ab into alpha plus beta. Plus ab into alpha plus beta is minus b by a. Again you can cancel a plus b square. Here LCM is needed. Outside I'm having a. When I square, minus will disappear. I will get b square by a square. 1a will cancel. No, I can't cancel. 2c by a. Multiplying with a, dividing with a, trying to take LCM. Here plus into minus is minus. B into b is b square by a. After cancellation, I will have AC plus into minus is minus. B into b is b square. plus b square. Both b squares will get cancelled. A is outside. A square is the LCM. B square minus 2AC in the numerator minus B square by A. One A will get cancelled. In the denominator, I am just having AC. So finally, B square minus 2AC by A minus B square by A. This AC by 1 will become 1 by AC reciprocal. A is the LCM. B square minus 2AC minus B square into 1 by AC. B square cancel. So minus 2AC by A minus 2AC by A into 1 by AC. AC will get cancelled. Minus 2 by A remains.